We're going to start our discussion of 8.2 and 8.3 algebraic vectors. So we kind of looked at them geometrically today. We're going to look at them algebraically, which means we're going to put them on the coordinate plane. So let's pretend we drew a vector from the origin to the point 3, 5. We'd called it vector 3, 5, and we draw it with those cute little pointy brackets instead of parentheses. The cool thing is you can move it anywhere around and it would still be the same vector 3, 5, because we define vectors to go from an initial point to a terminal point. So if the initial point is some point x1, y1, and the terminal is x2, y2, then the formula for what the vector is, well, you subtract your two x values and then you subtract your two y values. So if we wanted to look at an example, let's say we were going to draw from 7, -3 to -2, -1. We would subtract the two x values, -2 minus 7, and then we would go -1 minus -3. So our vector would turn out to be -9, 2. The distance is what we call the magnitude. So that means we just have to go back and find the distance between them, just like we would in the distance formula. We've actually done most of the work because -2 minus minus 7 and -1 minus -3 has already been done. So your distance is root 85. If you're adding vectors, don't make it harder than it has to be. Add your two x values, add your two y values. So you can see in this example our vector would be 8, 9. If you want to subtract them, no secret here. Subtract your x values, subtract your y values, and you're good to go. In this case, it'd be 0, -3. There's something called a scalar multiplier. It's kind of like the distributive property. If you multiply a vector by a number, just distribute that into your vector, and there you go. If you take a quick peek at number 6 on the 8.2 worksheet, they ask you to add two vectors that have scalar multipliers. So I'll let you watch how I do that one, and you end up with the answer of -1, 11. Last thing I'd like to discuss is what's called the unit vector. And I'll give you a little more reason why we talk about unit vectors, but basically in 2 dimensions, I is the horizontal unit vector and j is the vertical unit vector, 0, 1, and 1, 0. Okay? If we wanted to go into 3 dimensions, we have to add a third dimension, which in unit vectors we call k. So the two vectors I and j aren't much different, but k would be the third one. And I'll show you how to use it real quick. So if I gave you a vector, and this is the last example on the sheet, of -6, -11, and said write it as the sum of the unit vectors, well, that's in 2 dimensions, so that's got to have an I and a j. It's -6 horizontally and -11 vertically, so there's your vector as the sum of the unit vectors. If you wanted to find the distance, you're just finding the distance, so you'd have to use the Pythagorean theorem, 6 squared, 11 squared. There you go.